Hello everyone, this is Sriharshitha Salendra, working as an assistant professor in the Department of Chemistry at Mallareddy Engineering College. Today's topic is corrosion control methods. As we all know, when a metal is exposed to environment or when it is exposed to environmental gases or atmospheric moisture or when it is exposed to acidic or basic medium, the metal gets corroded, right? So, if the metal gets corroded, there are many disadvantages, right? So, what are the disadvantages? The metal loses its property, like its metallic properties, like physical or a chemical properties, right? And the metal undergoes rusting such that in the vast area, like in the industry, what happens if the equipment or the metal gets rusted? What happens? There will be a huge loss in economy, right? So that is why there is a need to protect the metals from corrosion. Okay, so those are called corrosion control methods. Okay, so to protect the corrosion of a metal means to control the corrosion, they are types of corrosion control protective coatings, cathodic protection, modification of environment by proper designing of metal and by using from pure alloys or metals, right? So in this video, we will only discuss about protective coatings. So what are protective coatings? Protective coatings are nothing but to protect the metal from further corrosion, we need to coat the surface of the metal. So that process is called protective coating. Okay. So in this, we are going to learn about metallic coatings. Okay. Metallic coatings means nothing but here we are going to protect the surface of the metal by coating it with an other metal, right? So if you want to protect the iron metal from rusting, so the surface of the iron metal is coated with the help of another metal. So that another metal is going to protect the iron from rusting, right? So here the metal to be protected is called base metal, and the metal which is coated on the surface of the base metal is called coat metal, right? So this metallic coatings is of, so one is hot dipping, plating, and electroless plating. Okay. So what is hot dipping and what is electroplating and what is electroless plating? These things we are going to learn in the today's session, right? This hot dipping is of again two types, that is galvanization and tinning. So, but in this video particularly, we are only going to learn about galvanization process. Okay. So coming to hot dipping. So hot dipping is a method of coating a low melting metal such as zinc, tin, lead, aluminium, etc. on the surface of the iron or steel metal, so which is relatively a higher melting. So hot dipping is nothing but we want to protect the iron metal. We have to coat the iron metal with a lower melting point metal like zinc, tin, lead, aluminium. So why we are going to coat the iron metal with the lower melting metals? Because there is a chance if the melting points of the coat metal is higher than that of the iron metal, the iron gets dissolved in those metals. So that is why we have to choose always a lower melting point metals like zinc, tin, lead, aluminium to coat on the surface of the iron metal. Okay. So as I said, hot dipping is two types, galvanization and tinning. So let us study what is galvanization process. Galvanization is a process of coating iron or steel with a thin coat of zinc to protect the iron from rusting. So as I said, here the base metal is iron metal and the coat metal is zinc metal, right? So here there will be a formation of thin layer of coating of the zinc metal on the surface of the iron metal. This process is called galvanization. Okay, so you have to clearly remember in galvanization process we are using only zinc metal as the coat metal and the base metal is the iron metal which is to be protected from the corrosion. Okay, so here what this zinc metal is will this zinc metal will be in the molten form. Okay, the iron metal is dipped in the molten state of zinc, which is maintained at 425 to 430 degrees centigrade. So in this hot temperature or in this hot conditions only the iron metal is dipped inside the molten zinc metal such that there will be a formation of thin protective coating of zinc on the iron metal. Okay, so let us study the process of galvanization. Okay, so before the iron metal or the base metal to undergo galvanizing process, so that has to undergo some surface preparations. Okay, what are the surface preparation it will undergo? Let us see. Right? So suppose consider this is an iron metal or iron sheet, right? So this sheet is dipped into the a caustic solution. Okay, what is the first process or the first step to be done in the surface preparation means the iron sheet or the iron metal has to be cleaned with a caustic solution. So why we have to clean this iron metal in the caustic solution means if the iron is having any kind of tiny particles or any kind of impurities that has to get washed. Okay, that has to get cleaned. So that is why we are first doing caustic cleaning. So after the caustic cleaning, we have to rinse it with water to remove all the caustic substance present on the surface of the iron metal. So after that process, we have doing pickling process. Okay, we are doing pickling process. So what is pickling process? Pickling process is nothing but it is a solution of dilute H2SO4 or dilute HCl. Okay, so this iron metal or iron sheet is dipped into the a solution of dilute H2SO4 or dilute HCl. That process is called pickling process. So why we have to do this pickling process means whatever the caustic corrosion is formed on the surface of the metal that has to get removed before galvanizing process. So that is why we are doing this pickling process. So this pickling process is done to 15 to 30 minutes. So after that, again, we are rinsing it with water to remove all the excess of HCl or H2SO4 which is present in the surface of the metal. Okay, so that is why we are going to rinse the surface metal by using water to remove the excess pickling. So after that, this metal is dipped in a flux solution, which is ammonium flux. Okay, this metal is dipped in a flux solution. So here after this process, then the metal is ready for the galvanizing process. Okay, so here in the galvanization process, we have a molten zinc bath. Okay, that metal is dipped in a hot molten zinc bath, which is at temperatures 225 to 425 to 430 degrees centigrade. Okay, so at this temperatures, that iron metal is going to dip in this hot zinc bath, right? And after that, we can see the thin coating of zinc on the surface of the iron metal. Okay, so the excess zinc is removed by annealing process, right? And after the annealing process, this metal is cooled to room temperatures such that the coat metal and the base metal gets uh, gets stickly form a thin coating on the surface of the base metal. Okay, so this is how it looks after the galvanization process. Okay, so this entire process is called galvanization. Okay, so what are the applications of this galvanization? So it is mostly used to protect iron, okay, which is used for roofing sheets, right? And wires, pipes, nails, and bolts. Okay, in all these things, we can see a galvanization that is nothing but iron metal is protected by a thin coating of zinc metal. Okay, and we can also see in buckets, iron buckets. Okay, zinc coated iron buckets will be there. Okay, so in all these things, it is applicable. Okay, so this is about galvanization process. The next topic is electroplating. So what is electroplating? Electroplating is nothing but we are going to protect the base metal by coating it with a coat metal by using electrolysis process. So what is the principle here? Principle is electrolysis process. Okay. So the process of depositing the coat metal on the surface of the base metal or a non-metal by electrolysis process is called electroplating, right? So electroplating of copper on the iron article is as follows. Here we are going to protect the iron metal and the coat metal here used is a copper metal. Okay. As we all know in electrolysis process, we need an anode, we need a cathode, and as well as an electrolytic solution. So here an electrolytic solution is copper sulfate and the temperature maintained is 40 to 70 degrees centigrade. So very low temperatures have to be maintained for a smooth surface to get a smooth surface of a copper coated on the iron metal, right? And the current density, electrolysis means definitely we need a direct electrical current source, right? The anode and cathode are directly connected to a DC current source. So, and that current density has to be 20 to 30 milliampere per centimeter square, right? And here anode is copper pellets and cathode is the base metal that is nothing but iron metal. Okay, So these are the conditions for electroplating of copper of iron metal. Right? Let us see the process. So as I said, it is a principle of electrolysis process. So in electrolysis, we need electrolytic solution here, that is copper sulfate. So as we all know that will be moving from anode to cathode, and the current will be moving from cathode to anode, right? So, so while this process, what happens means the copper ions get reduced and then gets attracted or deposited on the surface of the base metal like a thin coating, right? So it forms a thin protective coating on the surface of the base metal and such that this base metal is protected from further corrosion, right? So, ma'am, you have a question like how do we know these copper ions are deposited on the base metal? So we can know by calculating its density. Okay, if you observe the density of this after this electrolysis process or electroplating process, if you observe the density of the anode, okay, the density of the anode will be less comparatively to the density of the cathode. So by that you can say the copper is deposited on the surface of the base metal and it formed a protective coating on the surface of the base metal, right? So this is how the electroplating process is done, right? So coming to its application, this process is widely used in industries and decorative arts to improve the surface qualities of the objects, such as the resistance to abrasion, reflectivity, electrical conductivity, or appearance. Okay. So if you can see like decorative items, those are nothing but jewelry, right? Copper coated jewelry will be there, and and also you can see the phone cases, right? The back pouch of the phone will undergo this kind of electroplating process. Okay, so like that decorative arts. Okay, and industries to improve the electrical conductivity of the metal, right? And also it will resist the corrosion. Okay, to resist the corrosion of to resist this metal has to resist the corrosion, right? So in that way, so this electroplating process is applicable. Okay, so the next electrolysis plating is same as electroplating, but the only difference here we are using a suitable reducing agents instead of direct electrical energy source. Okay, so in this method, uh, the deposition of a metal from its salt solution on a catalytically active surface by using a suitable reducing agent and without using any electrical energy is called electrolysis plating, right? So here in this process, the metal ions are going to react with the reducing agent and it forms metal plus a protective coating on the surface of the surface of the base metal. Okay. So Let us see the process of electrolysis plating of nickel. So, if you want to take a base object, a plastic material, so um, you can take a metal, or you can take a plastic material like ABS. So the abbreviation of ABS is acrylonitrile butadiene styrene. Okay, so that can be coated with nickel, and the base metal is dipped in a solution of nickel chloride, sodium hyposulfide, that is nothing but a reducing agent, sodium acetate buffer. So buffer is used to maintain the pH of the bath solution, and sodium succinate is used as a complexing agent, right? So the pH of the bath solution is maintained at 4.5, and the temperatures is maintained at 93 degrees centigrade. Okay, so this is a reaction how it happens. So here nickel is going to react with the reducing agents in a presence of a suitable catalyst, right? And here the nickel metal is diffused out, and this nickel metal is formed as a thin layer of coating on the surface of this plastic material, that is acrylonitrile butadiene styrene. Okay, so let us see the applications of electrolysis plating of nickel. So here the plastic objects are used for decorative items. Okay, so these electrolysis plating of this plastic material, that is nothing but acrylonitrile butadiene styrene, are used for different decorative applications in automotives, in electronic, and also in the domestic or industrial purposes. Okay, so these are the application of this electrolysis plating of nickel. Okay, uh, thank you.